Okay, so here's our wonderful panel. Just a quick introduction. Everybody's talking about chiplets now. The whole world apparently hinges on before AI and after AI, if I actually believe what was said in the last 3 days. But I think the foundation for all of that is when you get down to the building blocks, it's really the chiplets. So we all believe that that's the new reality. So in order to have this open chiplet economy, what does it take from the big players who've been talking about the AI revolutionizing our worlds to the startups who want to be part of this? So how do we all coexist in this new reality? And with me today, we've got Kash, David, James, and Shahab. And with that, I will give the mic to Kash. You can do that.
Hello? Yeah, it's working. All right, well, welcome, and thanks for giving us the time to talk to you. The subject is enabling the open chiplet economy. Frankly, a lot of people have been talking about this for a long, long time, and hopefully, we're all working towards enabling that. So talk a little bit about YorChip. We're a small startup company. And we're trying to address the common problems that a number of people have raised when they really start scratching the surface. One of these is, how do I know that things are compatible? How do I know that things are interoperable? So in fact, the first chiplet that we have sort of announced in a partnership with an FPGA company is an FPGA chiplet. And the plan is to have a couple of different PHYs on there. UCIe will be on there. There will be a bunch of wires on there. And then the FPGA can be used to validate the link layer. And as you also know, FPGAs are really good at connecting things. So you could imagine one chiplet using a bow interface, potentially being connected to a UCIe interface, right? So that's one of the key things that we think is pretty important. The second thing is, FPGAs are pretty good at fixing bugs. I know nobody else is ever going to have a bug in their link layer. When it's implemented, it's very expensive. It'll be very expensive to change your chiplet with lead time. So having the ability to actually have a modification to that link layer on the FPGA to enable something that works, I think is going to be attractive. The second thing that we really address is something that actually I think Mark did a fantastic job. It's great when you see this interop of chiplets of different sizes. The challenge becomes when you want to actually connect different chiplets that were designed at different times, potentially in different technologies. And they don't all line up. It's very expensive to just try and test if they work. So we've done one innovation, which is that we actually have a version for high ESD, which we select with an RDL layer. And that allows us to actually put these at lower speed, maybe about half the speed that we can achieve die-to-die, in a chip scale package. So the idea is that you don't have to do an interposer. You can just go to market by getting chiplets that are in our package and actually evaluate if it works. You could even go to production with that, and then later on do a substrate. A lot of people, when they actually look at the cost of substrates, they're kind of surprised at the overall cost, and lead times and design requirements. So I think it's really important to enable chiplet ecosystem to really get rid of the friction of adoption, right? Make it easy for people to work with you. So that's the key presence of what we're trying to do. And there's this incredible discussion about interoperability. Some folks are of the view that you just build an ecosystem, and as long as it interops, you're okay. And other people on the, you need to be very precise, and we won't get into that argument. But in my view, to really scale this, it's a major friction point if a customer has to spend a lot of time trying to figure out if it's going to interop. So we're on the bandwagon of making it as easy as possible, spend the time up front to make sure that things interoperate. So that's part of the reason actually we're doing the FPGA, so that we can make that interop easier. The second thing is, as I said, the ROI to adoption. The moment a small or medium-sized group, it could be in a large company, figures out they've got to buy new tools, they've got to add engineers that know about this SIPI stuff, and let's not forget about how to do a test program from 3 different chiplet vendors. You may never have done a high-quality test program within your company, right? It really starts to become a huge adoption barrier when you really look at it. And that's the key essence of what we're trying to eliminate. So that's what I got to say. Next.
Shahab. Oh, you're the last one? Oh.
Your size next.
Okay.
It's David.
Okay. Testing? All right, it's finally working. Okay, so you're going to hear a lot about reducing the adoption barrier, and that a lot of work needs to happen upfront when we are trying to put chiplets together. And there are many multiple aspects that go into that. I was actually prepared to talk on a panel that was going to be 2 minutes, so I have 2 really quick slides. Now I have 7 minutes, so I'm going to give you the long spiel. There's multiple aspects that go into trying to figure out how do we build chiplets together. One of the important, actually, I see the what's happening with the chiplets as a once in a lifetime opportunity. The reason is what we need to do. What my vision is, we need to bring the chiplet design flows to where the silicon flows are. Right? For silicon flows, anybody can integrate multiple libraries from different vendors on the same technology and not think about it. And the reason that happens is all about models. That you have the upfront models, they're well-defined, and you can combine them all together. So part of the work that's happening in CDX and ODSA is we are trying to define models that you can interoperate. That gives the flexibility of vendors to provide one model and make sure that, and they would know that that can be used by multiple customers. And customers know that they're getting the same model from multiple vendors and that they are compatible. And when they put them in the same place on the same system, they would actually work together and they would play together. The second aspect of this is, okay, we have built all these models and chiplets, but how do we, where do we find them? And one thing that we have done is cataloging, a place where you can go and find different options for substrate, different options for chiplets, different options for IPs, materials. They would all be defined with the same models, and then you can pull those in and test them and see if your system makes sense. Workflows is actually the third aspect, right? We need to have a predictable workflows that you know how you put things together. That's important for vendors. They would need to understand how their chiplets would be used and how would be put together. They can specify those in the models. But then on the integration side, you know what workflow you have to go through to build this whole system. And we are working on a white paper in CDX that describes some of these workflows. It's very complicated. It's 95 pages already. You're going to see it sometime later this year. But really, one thing that is unique about chiplets is when we're talking about models, we are not talking about the logical models or Liberty models, power models, things like that, right? We are now talking about manufacturing models, assembly models. We are talking about system models. How, especially on the assembly side, you have heard folks talk about, are chiplets compatible? How do I know that chiplet A with bumps of type A would be compatible with my substrate? How do I know that? Right? We don't know that. Right now we don't, and we have to go read through PDF data sheets and try to figure it out, and we hope we get it right. The key is to build the models to do that. And all of that comes, you're going to hear about shift left on the flows, and really the idea is you start early with the architecture, you have to explore all the manufacturing options, all the supply chain, you have to figure that one out. You cannot wait 12 months to figure out this, to figure out your supply chain and find out that, oh, I can't get this package, it's not compatible with this chiplet, I have to go back and have to change everything. So early exploration is key. How much time do I have? 3 minutes, all right. Okay. So if I don't fit in this time slot, you're welcome to come by the Experience Center, and I can give you the long demo. But really, we have. Wait, this is the old slide. Okay, so we have a chiplet catalog, and we would like to open that up with multiple options. Right? We can work out the mechanics of how we open it up to you, depending on what your business needs are. But really, it's sensitive to the fact that there's public data that you need to have and need to share, and there is private data that you would share only to people that you really want to share with, right? You would definitely not give your IBIS models to the whole world. But as a vendor, you would like to, if you're providing IP, you would like to say, hey, I'm providing this IP, and I also will provide LEV, DEV, IBIS, and things like that, whatever you have, so that a customer would know I can immediately use this if I choose this company. Second thing is so we built this on top of CDXML and JEP30. This is the new standard that came out from collaboration between ODSA and JEDEC. And thank you to Elad for plugging that collaboration. But really, it's an open standard. It's accessible to everybody, and it's standard, right? You know what's in it. You know that if you pull it in, it will work for you because everybody is working with the same standard. The implementation of that, of the next piece is being able to pull that data for different chiplets, put them together, see if they are compatible, see how the routing would look like. Are wires crossed? Are interfaces aligned? What do I need to align them? How far can I move them? You know, all that stuff is not doable by hand anymore. HBM3 has 2,000 wires to connect between the memory and the chiplet. So if you're trying to do that by hand, forget it, it's not humanly possible. And if people talk about 6, 8, 10 HBMs, we're talking about looking at tens of thousands of wires, right? So we have quick automation to kind of look at that, to explore it. Then the next one is look at power. Everybody cares about power for a good reason. And on one side, you have power. I have a funny story about talking to VCs about power and thermal, but come by and I'll tell you that at the booth. On one side is power, and on the next side, you have to look at thermals. You have heard previous talks about thermal crosstalk. Things are not intuitive in thermals at all when you have multiple chiplets that operate in different modes and things are going on and off. And you have heatsink on top and substrate on the bottom, and you have the voltage regulator somewhere and the PCB, how that all links together, how they talk to each other, you know, what the thermal coupling is. It's not intuitive. I wrote the solver, and I can tell you I cannot predict it, how it's going to look. So you have to run quick simulation and be able to find out if that system is feasible or not. So I'm going to about conclude now. I think I'm about my time. So workflows, models, it needs to be open. We have implemented based on open standards. And these are very exciting times.
So one quick comment is I suggest all of you look at David's catalog. It's actually pretty cool because it doesn't require left, def, or other proprietary information which a company may not be willing to share, but it just looks at the bump out, and it gives you a first pass analysis of whether certain chips can be, or chiplets can be put together. And you know, because there's limitations of bandwidth density, what the beachfront looks like, and what your performance requirements are. So I think it's very cool. So if you get a chance to look at his demo.
Thank you.
And now we have James.
Why don't you have this chair?
All right. Thank you, Anu. Hi, everyone. I'm James here. I'm going to talk talk about, I think, some of the David has talked about earlier. There's a reason why. And again, thanks for everyone to be here. I'm from Palo Electron, so we are part of the Chiplet.US Alliance, which is the Thrace system and Enosemi system that David talked about, was part of that. There's a catalog that we're building, I think, David mentioned. So this is kind of like the, there's a newer version that I will be able to demo there. And what Palo Electron here doing is really specializing in integrating these chiplets together. So using the heterogeneous integration. So we have, in the past, we have done the active interposer and helped to glue all these chiplets together. We also have expertise in the advanced packaging technique, so we're able to work with you and work with the chiplet vendors, designers, product company to help them to build a custom chip by helping them to integrate all the chiplets together and also put it into the packaging and work with some of our partners. Here, more specifically, the services that we're providing, they are like the system design, subsystem design. So we do all the simulation and layout, design sign-off. We do have power and thermal that we partner with the Thrace system and Enosemi here, and we also do a SIPI. And verification side, we do have a die-to-die interface, bump plannings, verifications. And we also can do really a lot like prototyping, using active interposers that we mentioned earlier. So as pointed out earlier by David, we also part of the active participants at the CDX. We actually one of the pioneers for this CDXML, the standard data format that has been integrated into the JED30 recently, as announced, I think, in last week, and also in a couple of days ago in the OCP here as part of the keynote. So we are great to be have this standard format to be adopting in the industry. Some of the key important, I think, is showing here is especially, I think, really what this about CDXML is really focusing on chiplet integration. So the JED30 part model generally is for chip and components, the parts, but a lot not really kind of satisfying the a lot of HPC, especially the chiplet kind of interfacing. So one of the keys is we introduce the multiple instantiations of the interfaces. So allow you once you define group of the interfaces, you can kind of recreate that. So it's especially very good in this kind of multiple core kind of dial where you definitely have repeating kind of I/O that you can kind of reuse them so you don't have to recreate them. Another is more the 3D integration that we have defined the bottom and top and bottom terminals that you can traditionally you do a lot fixture kind of face down. Now you can connect on the top as well. So that's another key, and many others. And of course, there's a white paper. I think as David mentioned that we talk about the two things. One is the workflow. For the models, and another one for the workforce for the integration that's coming out in later this year. So we're really utilizing on this kind of open standard defined as part of the OCPs, ODS and CDX to using these kind of standards defined by many industrial experts. And you utilize in our workflow here, see the workflow here. From all the end to end, So we're going to make use of that CDXML, JED30 standard and plugin, and then you can get the standard format from all the way from initially from your chiplet selection and placements all the way to your simulation verification, like power, thermal, SIPI, all the way to a packaging, like testing, and even sign off and to manufacturing. So there are new things like, as Tony, I think if you guys were here in Java, right, presenting about this, like this 3D efforts, part of continuities of this as well. So beyond the standard like mechanical and electrical information, we also looking to define like material properties and also like the assembly rules, right? And all will be integrated here, so it will be provide a seamless integration. So yeah, we already partners with many of the startups here. So check out the chiplets.us, and we're also looking for more partners, vendors of chiplets, testing, manufacturing to partner with us. I think that's key important economies. I think to have also from the startup standpoint, I think that's why we have this startup ecosystem, right, to enabling chiplet developments within the startups, and it's also key also like for many kind of like small, medium-sized kind of companies that can utilize this kind of chiplet technologies to our ecosystems here. So yeah, so welcome to check out on us. Right, thank you.
Thank you, James. And last but not the least, we have Shahab.
Thanks. Thank you, everyone, being here. I'm going to stick to the original plan, just 2 minutes talk. I'm from Enosemi. We are a startup on silicon photonics chiplet. Since it's a little bit related to the ecosystem, I just want to talk about some of the initial decision that any startup has to make when it gets to the chiplet. I think the first one is what kind of PHY do we need for this chiplet? As a startup, you cannot afford basically to develop and implement all the possibility of the PHYs. Either you have to toss a coin and pick UCIe, BO, or anything, or your strategic customer is going to push you to that front. For us, it was a little bit different. We had the option to basically develop electronic to optic conversion, be somehow not related to the PHY, becomes basically PHY agnostic. And we say, okay, our chiplet accept any kind of electric PHY that you have for your own chiplet. It could be BO, it could be UCIe, XSR, or anything. There are other options also when it gets to the photonics. We have to make that decision. Should the chiplet of the photonics be also multiple die or a single die? You can implement photonics in different process and electronic in different process and then combine them together with the 3D or 2.5D integration or 2D integration. The decision that we made was, okay, let's go for monolithic because we believe we're going to basically reduce the cost and challenge of the integration of the chiplet with the original ASIC. With all those things that I mentioned, basically we picked out the PHY agnostic solution, which E2O or O2E engine is a kind of direct drive. We can receive anything from a couple of gigahertz all the way up to 112 gig PAM4. And we decided to be 16 channel. On that, all the solution, TX and RX, photonics, electronics, everything is monolithic in one chip. Excluding the laser, we are burning 4.3 picojoule here, and we are ready basically to get integrated for any kind of ASIC that you have and convert that PHY that you have to the optical one. What do you want to do with that is more for more reach, basically. Some may actually question me, why do we need basically optical there? I think everybody's talking about disaggregation, and if you want to go longer reach, the optical is the solution.
You really stuck to time. Thank you, Shahab. So now we can, somebody can sit here. We can open up to questions from the audience. Bapi said he had a question. Yeah, I know.
I think all the panelists forgot to tell you that they're pre-funding startups, early stage startups, and they're looking for money. So you better check none of them check.
Yeah, check out all their booths for sure. Yeah.
And well, that was my question.
Okay, so one question to all of you. I'm hearing this PHY agnostic way of doing things because we are in limbo as an industry, right? UCIe is developing. There's a lot of force. There's a huge force behind that. The bunch of wires is standard. There's differences, as pointed out by both Debendra today and Elad on what's the difference. So for a startup to be successful, is being PHY agnostic the only way to go? So you're not stuck in either camp? Go ahead, whoever.
I think it's difficult if you want to say for all the functionality that you're adding as a chiplet to be PHY agnostic. But it's actually the difficult question to be. Just imagine 4 or 5 years ago if you have picked AIB or HBI. You know, you're stuck with a couple of $1 million tape out. It's expensive. For our solution, it's a little bit different because we have the option to be PHY agnostic and convert to optics. But for some of them, there is no option. If we can be PHY agnostic, it's much better, or we have to wait till one of these things becomes basic.
One ring to rule them all.
Correct.
Yeah. And Kash, your IP has both.
Yeah, I think to be honest, it's critical because I think, to your point, I think that both approaches actually have a lot of merit. And it's pointless arguing about which one works better. If you look at it, it's pretty clear which ones work better for different applications. And I actually see both being used. I think anybody who's developing a chiplet that they actually expect to use across, a broad range, probably should look at supporting both. So that's my, and that's what we're doing with our FPGA. Yeah.
Oh, hi. This is Nilesh. I had a question. So about being PHY agnostic. So if you're an IP company that just wants to sell IP in a chiplet format, let's say compression IP, or maybe it's a new type of memory management IP, or an actually new form of memory. What's the best way or the most scalable and for a startup way to approach a chiplet? Is it to partner up with someone who's building the chiplet platform, and then they could just insert the IP and focus on that, or do you have to essentially become a chiplet expert and do the whole thing?
Yeah, so this is part of my sales pitch, actually. So yeah, I think that just some IP. If you're an IP company, and I've been in the IP business for a long time, or was in the IP business for a long time. So if you have unique IP, it takes a long time to win a design. It takes a long time to differentiate against the big guys, and it takes and the revenue is somewhat limited. So I think chiplets in general are a win if you have really good IP. If you can put it into a chiplet with somebody, us or someone else, it doesn't really matter, right? Because there's an opportunity for IP companies to now start getting recurring revenue, right? And customers you're much more likely to win the deal against an IP company that doesn't have a chiplet that a customer can prove out, particularly if it's novel technology. So if I was you, I would at least consider that.
Okay, Bapi's kicking us out, so we're done. Thank you. Thank you very much.
Thank you, everyone.